Good morning, Algebra 3. It's time for us to touch back with the quadratic formula that I know you had in Algebra 2, but we want to stretch it a little bit and talk about it a little bit more deeply. We know that the quadratic formula is derived from completing the square, and we do that using all variables, but that's where it came from. But we, of course, are more interested in being able to use it. So in order to use a quadratic formula, it's got to be an equation that's in quadratic form. In other words, it has to have a number times an x squared term plus a number times an x plus a constant and equals 0. Now these variables here are x's, but they could be whatever variable you want as long as they're the same variable. If there is no x squared term, in other words, if a is 0 and you just have really basically an mx plus b situation, you've got a line, it's not quadratic, so it doesn't really work in this formula anyway. So we've got to have a quadratic, a square, a linear, and a constant term in order to do that. Your letters, your coefficients are a, b, and c, and you pick them out to plug in to the formula negative b plus or minus the square root of b squared minus 4ac all over 2a. And that formula is good to commit to memory, because if you are going forward and doing something later on in it, it's just good to have in your toolbox as something that you can use. Okay, so if we're going to solve using the quadratic formula, the first thing you need to do is, of course, identify a and b and c. And those are just the numbers. Notice this one already is equal to 0, so that's the reason why we can pull out a, b, and c. And then you plug in. b is negative 5, it goes here and here. A and c are here, they go here and here, and then a gets pulled down into that spot. Do be careful, because minus, if it's next to a negative, turns into a positive. And a negative squared turns into a positive. So you've got to be super careful on your signs, or you end up getting wrong answers. That's the biggest problem that I see with quadratic formula. But if you're careful and you work this out, sometimes the number that you get under the radical is a perfect square. And if it's a perfect square, don't just leave your answer like this. You are responsible to go through and finish it. Okay, so 5 plus 11, 5 minus 11, square root of 121 is 11. And then simplify each expression. And don't stop until you've reduced those fractions, which we've already talked about enough that you should be able to reduce fractions, even if it's on the calculator. Okay, so quadratic formula can be used in these cases, and very nicely and efficiently. Especially since this coefficient isn't 1, it makes completing the square awkward. It makes all the other methods awkward. So very, very nice tool to have this quadratic formula. Okay. Now, remember we said that you have to have a 0 on one side. There's no 0 on one side, which means that we've got to subtract the 8x and add the 1 to both sides in order to make it so you've got a 0 on one side. Then the criteria are met. You have an A, you have a B, and you have a C. And then you can take those numbers and plug them into negative b plus or minus the square root b squared minus 4ac all over 2a. And these get filled in with numbers. Minus negative turns into a plus, as you know. Negative 8 times negative 8, positive 64. In this case, minus 16. We simplify that down. Now, here we have a situation where 48 can be broken down if we're looking for exact numbers. 48 can be broken down into 4 square root of 3, because 48 would be broken down into 2 times 2 times 2 times 2 times 3. So 2 2's would pop out, and we end up with our 4 square root 3. Now here's the thing. There's a common factor here, so you can factor out a 4 out of both of those. The reason we can do that is because now you have a product and you can cancel this out. So we can cancel that out because it's part of a product, but you can't cancel out part of a sum. So I wouldn't be able to cancel the 8's here. But once I've factored, I have factors, and factors can cancel. Sums or differences cannot cancel, but factors can cancel out. So this becomes a 1, this becomes a 2, because dividing numerator and denominator by 4. And I can't cancel these 2's out. I have to leave it like this, or you could, if you wanted to separate it, you could separate it into 2 over 2, which would give you 1, and square root of 3 over 2 if you wanted to. Okay? But you don't have to. You can just leave it like this. Now this one, in order to solve it, you need to try and get x alone, as we know, but you've got too much happening. This is not a perfect square, so we have to go ahead and multiply it out first. So it almost feels like you're going backwards to go forward. So I need to do 9x times x, 9x times negative 1, 3 times x, and 3 times negative 1. Then, of course, you know that you need to combine your like terms. But it's not just combining the like terms. We then have to add the 8 to both sides. So this is what happened. Here's our combined like terms, give us a negative 6. But when I add 8 to both sides, I get a 5. Factoring doesn't work nicely for that, so we're going to resort to quadratic formula, A, B, C, A, B, C, and then plug in. And, just for those that are thinking about skipping out right now because you're like, oh, I get this, hang in, there's something at the end that you need to see, and we need to talk about discriminants yet too. So negative b plus or minus square root b squared minus 4ac. 2a in the denominator, simplify everything. And yes, I know I'm going fast. Take your time on it. Pause as many times as you need. Here we have a negative, so it is possible to get an imaginary in there to get a complex number. 6 plus or minus 12i. Now in this case, we can factor out a 6 and get 1 plus or minus 2i over 3. Because the 6 and the 18 can cancel out. 6 was a common factor in those. Okay? So reminding you about imaginary numbers and factoring and canceling out as needed. Now what we've noticed is a couple of different things can happen. What number you get under this radical is important. Okay, because sometimes it comes out to be a perfect square like the first one we did, and when it was a perfect square, we could solve it down into having two very nice rational numbers. Okay, let's back up and take a look back at that one just real quick. Okay, when you had a perfect square, it simplified down to getting two rational numbers. When it was not a perfect square, but it was a positive number, we ended up getting, really this plus or minus means that we ended up getting two irrational numbers for an answer. But when we ended up with a negative underneath here, we ended up having, really, because of the plus or minus, two complex numbers as answers. So that number under the square root is super important, and sometimes we can just ask to find that. So if your directions say find the discriminant, then that is going to be what determines what type of answer that you're going to get. So a question could ask you to find the discriminant. In other words, we want that number that would be under the radical sign, b squared minus 4ac. If that number comes out to be a 0, then you're doing plus or minus of a 0, which means you get just one answer, one rational answer. It could be a fraction, it could be a decimal, it could be a whole number or an integer, but you get one rational number. If you have a positive number that's a perfect square, just like I just said, you end up with two answers and they're both rational. If you have a positive that is not a perfect square, we end up with two irrational numbers. In other words, there'd be a root left in your answer after you simplify. And if you have a negative discriminant, you're going to have two complex solutions. In other words, there'll be imaginaries in part in your answers. Okay? These all intersect the x-axis if you were thinking in terms of graphing. This does not if you have a negative discriminant. So various different things you can tell by the discriminant. So let's look at some examples here. Finding the discriminant means, of course, you've got to have it in quadratic form. And once you have it in quadratic form equaling 0, you find your a, your b, and your c, and you're looking for what b squared minus 4ac will give you. Here's b squared minus 4ac. We find the answer 361. 361 actually is a perfect square. And if you square root it, just do a quick square root on your calculator. And if it comes out to be a whole number, it's a perfect square, and that will tell you you've got two rational solutions. Okay? This one, 4, 1, 1 are our a and b and c. b squared minus 4ac. This gives us a negative number. Okay, so that's a negative number, not real solutions because it's under a square root, so we get two complex solutions. This is the type of solution. Sometimes it asks, in various textbooks, they'll say to tell the nature of the roots. This one, in order to be in quadratic form, you have to subtract the 5. 3, negative 4, negative 5. b squared minus 4ac. We get 76. That is not a perfect square, but it is positive, which means you have two irrational solutions. Okay? So that's that. One more thing to talk about. This one's the one that's a little bit different, is if you're trying to find out how much b equals under a certain condition. This one says, find k so that 9x squared plus kx plus 4 equals 0 has only one rational solution. Well, remember what one rational solution means. One rational solution means that the discriminant equals 0. b squared minus 4ac. We know a is 9 and c is 4. So we're looking for the number k squared minus 4ac is going to equal 0. So we do our calculations and we find out that k could equal 12 or k could equal negative 12. Either way, when you do k squared minus 4ac, you're going to end up with a 0, which gives you one rational solution. And that's really all we need to do for today. I will leave you to working on your assignment 74 that you need to do right now, and then have it ready to turn in on Thursday. Tomorrow you're taking a break. So enjoy your break, and God bless you. Have a great day.